In this video, I'd like to revisit some of the conversation that we had in class today. We've been talking about quadratic functions, and we made note of the standard form of quadratics when we have it written in ax squared plus bx plus c format. And we have another form, the vertex form, that's also very helpful for us to use in class. Our ability to convert between the two is pretty important, because sometimes equations are given to us in standard form while others are given to us in vertex form. And while I like standard form for solving quadratics, I like vertex form for graphing them. And so being able to navigate between both formats is going to be particularly helpful. So one method to complete some of those conversions is called the completing the square method. Completing the square is short for completing the square trinomial. In Algebra 2 classes, this technique is taught. In some pre-calc classes, it's taught as well. But if you haven't seen that method in a while, or if it's not something that that's coming back to you naturally as we practice, I do want to show you the alternatives to that. And so if we start with our function written in, let's go with the vertex form here. If we start with our function written in vertex form, I think we can come up with a couple equations that we can either memorize or add to our note sheet and use them for future reference. So the first thing that I'm going to do is I'm going to expand this, this equation. We'll write this as x minus h times x minus h, and then FOIL that together and distribute the a into it. So we'll write x squared minus 2xh plus h squared. And we can distribute this a in, so now we have ax squared. And notice how I'm going to distribute this here. I'm going to put the a in position with this group, and I'm also going to slide this h over. You'll see why in just a second. So we'll call this minus 2ah times x, and we'll add to that a h squared, and we have the plus k that's left over. So if I've distributed correctly, and we compare this, which is our modified form of the vertex form, I can compare that to our standard form, ax squared plus bx plus c. And what you might notice is that the a value from our vertex form is in the same position as the a value in our standard form. This negative 2ah is in the same position as b in our standard form. So the 2ah from vertex form is in the same position as b in our standard form. And then this whole combination of ah squared plus k, that's in the position of c in our vertex form. And effectively what we've shown is a shortcut formula, if you will, to convert from standard form into vertex form. Or I should say the other way, from vertex form into standard form. Here's what I mean by that. According to this statement right here, I know that a in standard form is the same as a in vertex form. I know that b in standard form is actually equal to negative 2ah in vertex form. And I know that c is equal to ah squared plus k. And so this group of three formulas allows us to take a known a, h, and k value, also known as our vertex form, and convert it into standard form. Now, some students would argue that this isn't really necessary, because when we convert from a vertex form into standard form, all we really need to do is expand the binomial and combine like terms. And I agree. But if we take these known equations and modify them a little bit further, we get another group of equations that can be used to convert from standard into vertex form. And that could be used to replace our completing the square method. So I'm going to look at this equation here. Well, first off, I'm going to note that when we convert in the other direction, a is still equal to a. But if I jump over here and this time try to solve for h, try to get h by itself. H would be the result of this b value divided by negative 2a. So I'm going to write this as negative b divided by 2a. We now have our h value. And our k value, if we were solving for it, well, all I would need to do is subtract this ah squared to the left-hand side. So we would take c and subtract ah squared. And if we didn't know what h was, we can say that c minus a times negative b over 2a squared. These two mean the same thing. Now, it's my opinion that if we're solving for k, we're also solving for h at the same time. So I'm just going to leave this equation as it is. And so a byproduct of the vertex to standard form conversion gives us this group of equations, which is our standard form. If we have a, b, and c, we can convert a, b, and c into a, h, and k, our vertex form. So again, this combination of formulas here is a good one to replace the complete the square method. If you've got further questions on that, please see me in class or send me a message and we can talk more about it further. Thanks for watching.